Today we're going to be looking at the 2015 Curriculum for Excellence Higher paper, Section 8 multiple choice. If you've not already tried this paper, I would recommend that you give this a try before you go over the video. You can use the video to help you mark it and to see where the working comes from for each question. Question 1. The elements nitrogen, oxygen, fluorine and neon can do what? So first of all, can they form negative ions? Nitrogen, oxygen and fluorine can, but neon does not form ions. Are made up of diatomic molecules. Nitrogen, oxygen and fluorine are, but neon is monatomic. Have single bonds between the atoms. Nitrogen has a triple bond and oxygen has a double bond. Neon has no bonds. Are gases at room temperature. If you have a look in the data book, you will be able to find they are all gases at room temperature, so D is our answer. Question 2. Which of the following equations represents the first ionisation energy of fluorine? If you look on page 11 of your data book, you can see the ionisation energies, and at the top of the page it has an example written for you how to write out ionisation energies, and it's written in this form. So you have element in the gaseous state to become element positive plus an electron. You must include the state symbols. The definition for the first ionisation energy is the removal of 1 mole of electrons from 1 mole of atoms in the gaseous state. So we need to have fluorine as a gas and as atoms, so that's F as a gas, becoming F positive plus an electron. So C is our answer. Which of the following atoms has the least attraction for bonding electrons? Attraction for bonding electrons is the definition of electronegativity. So you're looking for something which has the lowest electronegativity. And the lowest electronegativity here is silicon. Which of the following is not an example of a van der Waals force? So there are 3 types of van der Waals force. London dispersion forces, permanent dipole attractions, and hydrogen bonds. So the answer here is A, covalent bond, which is an actual bond between atoms. Question 5. Which of the following has more than one type of van der Waals force operating between its molecules in the liquid state? For A, we have a pure covalent bond, so this is going to be London dispersion forces only. For B, although carbon and oxygen are polar bonds, this molecule is symmetrical, so this has no permanent dipole interactions, so that's London dispersion forces only as well. NH3 has polar bonds, and they are an N to an H, which means that this is hydrogen bonding. And all molecules have London dispersion forces, so this has both present. And this finally here is a symmetrical molecule, so only has London dispersion forces. So the answer is C, ammonia. Question 6. Oil molecules are more likely to react with oxygen in the air than fat molecules. During the reaction, the oil molecules are A, reduced. Reduced is either the gain of electrons or hydrogen, it is not that. Become rancid. This is what happens when things tend to react with oxygen. Are hydrolyzed. Hydrolysis is where we split up with water, we have no mention of water here, or become unsaturated. If they were to react with oxygen, the chances are it would go the other way and the oxygen would react with the double bonds to make it more saturated. So your answer is B, become rancid. Which of the following mixtures will form when sodium hydroxide is added to a mixture of propanol and ethanoic acid? So if we draw out some basic structures here, so here is propanol, I've not shown the hydrogens, and ethanoic acid. If we were to react these two together with sulfuric acid catalyst, then you would get an ester. However, we don't have that. So sodium hydroxide is going to react with one of these. It won't react with propanol, so we should end up with propanol at the end, but it will react with ethanoic acid to form a salt, so it will form sodium ethanoate. So if we have a look at our answers, here we've got propanol and sodium ethanoate. So that is the answer. Oils contain carbon-to-carbon double bonds which can undergo addition reactions with iodine. The iodine number of an oil is the mass of iodine in grams which will react with 100 grams of oil. Which line in the table shows the oil which is likely to have the lowest melting point? So to have the lowest melting point, you need to have the most unsaturation. The more unsaturated the molecules are, then the harder they are to pack together, which means that they'll have weaker van der Waals forces between them, so they'll have a lower melting point. To be more unsaturated, you need to add the most iodine to be able to saturate the bonds. So we're looking here for the highest iodine number, which is for linseed oil, which is B. 9. When an oil is hydrolyzed, which of the following molecules is always produced? So if we draw out a quick sketch of an oil molecule, so here we have the part of the molecule that's came from glycerol, and here we have our 3 fatty acids. When we hydrolyze this, we break it here. The R's can be either the same or different, so this will change for every fat or oil that you hydrolyze, whereas this bit will always be the same and will always produce glycerol. So glycerol is this molecule here, B. Question 10. Enzymes are involved in the browning of cut fruit. One reaction that takes place is between this molecule here and oxygen to produce this and water. Which of the following correctly describes the above reaction? So we're reacting this with oxygen, and you can see that we're taking the OH groups from being OH to being carbonyl groups, which means that we have an oxidation reaction. Which of the following statements is correct for ketones? So ketones are compounds which have the carbonyl group in the middle of a chain, so this would be a rough drawing of a ketone. So they're formed by the oxidation of tertiary alcohols. Tertiary alcohols cannot be oxidized because there's no hydrogen attached to the carbon where the OH is, so that one isn't possible. They contain the group CO double bond OH, that would be an aldehyde. They contain a carboxyl group, that's a carboxylic acid, and they will not react with Fehling solution. This cannot react with Fehling solution because we don't have a hydrogen here to be allowed to be able to oxidize further to a carboxylic acid. So the answer for this one is D. Question 12. Carvone is a natural product which can be extracted from orange peel, and you're shown the structure of carvone. Which line in the table correctly describes the reaction of carvone with bromine solution and with acidified potassium dichromate? So with bromine, we can react with this bond here, so we would expect it to decolorize, so that would be C or D. And with potassium dichromate, the reaction would be with this part here. However, this is a ketone and not an aldehyde, so there cannot be a reaction. So the answer is D. The structure of isoprene is what? To be able to answer this, you really need to know the full name of isoprene, which is 2-methyl buta 1,3-diene. So if we were to draw that out, we would have 1, 2, 3, 4 carbons with double bonds between 1 and 2 and 3 and 4, and on the second we would have a CH3 group. So you just need to match this structure up to one of these, and you'll see there that it is B. Question 14. The antibiotic erythromycin has the following structure. To remove its bitter taste, the erythromycin is reacted to give the compound with the structure below. Which of the following types of compound has been reacted to produce this compound? So you need to compare the two structures and see where something is reacted. So this part here was in the original structure. You can see that there. So the part that's been added on is this bit here, and you can see that we have reacted that with the OH group here. So we've created an ester, whereas this was an alcohol. So to create an ester, we needed a carboxylic acid. So the answer is C, carboxylic acid. Which of the following is an isomer of 2,2-dimethyl pentan 1-ol? So first of all, we'll just draw out 2,2-dimethyl pentan 1-ol. So we have 5 carbons. On the first carbon we have an OH, and on the second carbon we have 2 carbon methyl groups. The first thing you need to check is which of these has the same number of carbons, and then go from there. So we've got 7 carbons in total, so this is C7. So if we check that first, 1, 2, 3, 4, 5, 6, so C6 can't be that one. We've got 1 times 3, so that's 3, 4, 5, 6, 7, so that one's a possibility. 1, 2, 3, 4, 5, 6, 7, 8, C8 is too many. We've got 1, 2, 3, 4, 5, 6, 7, 8, another C8. So our answer here has to be B, because that has the same number of carbons, and if it's going to be an isomer, it needs to have the same number of carbons. Question 16, consider the reaction pathway shown below, and using Hess's law, we're trying to find this reaction here. So if we're going from W to Z, we have minus 210, and if we're, so W to Z is our initial reaction, and that would be equal to W to X plus X to Y plus Y to Z, because the pathway here has to be the same as going around this way. So if we've got minus 210, we have minus 50, minus 86, plus whatever this happens to be. So if we work that out, find that that's minus 74. That's going from Y to Z. We need to reverse it because we're trying to go from Z to Y, so that would give us A. Question 17 looks harder than it is. You're given a lot of information, but you just need to work through step by step to see which information applies. So the first step for all of them is that we're turning I2 solid into I2 gas, which is plus 60, and you can see that all of them have that as an up arrow, so we've used that. We're then taking the gas and we're turning it into atoms, so we're atomizing it. So we have a look here, we've got I2 gas becoming 2I gas, and we've got the right value for that here. Here, this isn't the correct value. Neither is this one, but this one is. So we're between A and D now. We're then taking the moles of gas that we have and we're adding electrons on. So the equation here shows 1 mole, we're doing 2. So for 1 mole it's minus 349, but we're trying to do 2, so it can't be that one, we have to double it. So D is our answer. Question 18. Which of the following statements regarding a chemical reaction at equilibrium is always correct? The rates of forward and reverse reactions are equal. That is the definition of your your equilibrium. Concentration of reactants and products are equal. They can be different. The forward and reverse reactions have stopped. They've not. It's a dynamic equilibrium. The addition of catalyst changes the position. It just gets you to the same position but quicker. So your answer for this one is A. Question 19. A reaction has the following potential energy diagram. The activation energy for the forward reaction is what? So the activation for the forward reaction is the energy needed to get to the top of this hill. So it will be X minus Y. Okay, if you were going to go backwards, it would be X minus Z. And if you were looking at the enthalpy change, it would be Z minus Y. And finally, question 20, which of the following will react with Br2 but not I2? For this, you need to have a look at the data book, and you have to use the anti-clockwise rule, where your reactant needs to be above bromine, so that it'll react with that, but below iodine, so it won't react with that. And you will find that the only one which fits that is Fe2+. Thank you for watching this video. I hope that you found it helpful. Please remember to subscribe and follow me on Twitter at MissAdamsChem for regular updates on new videos. Bye for now.